Dear students, in this class, we are going to see the properties of the Smith chart. You know very well, in the last class, we have seen the construction of the Smith chart, which consists of two types of circles, R circles and X circles. And already I told you how to draw the R circles and X circles. And in this class, let us study the properties of the Smith chart, because we are going to do so many number of problems using the Smith chart. Now, once again, let us come to the Smith chart. The Smith chart is having two types of circles, constant R circles as well as constant X circles. So, these circles are nothing but the R circles constructed based on the circle equation. So, from that circle equation we know the center of each and every circle is nothing but R by 1 plus R and 0, and the radius is 1 by 1 plus R. I am using small letters here because these letters are telling that it is normalized resistance, normalized values, because you know Smith chart is nothing but the polar plot of R circles as well as X circles in the complex reflection coefficient plane. And this entire Smith chart is always telling about the normalized values. So, whenever you are using this Smith chart, you should normalize all the values, then only you have to use this Smith chart. So, coming for this R circles, its center is R by 1 plus R and 0, and its radius is 1 by 1 plus R. Based on the circle equation, we have drawn all these circles for different values of R. And this R is equal to 0 means 0 by anything is equal to 0. That means center is 0, 0. And 1 by 1 plus 0 means 1. So, radius is 1. So, this outermost circle is called as, this is unit circle. Unit circle. So, all other circles will be inside this unit circle only. That means the maximum range of this R circle is, this is the unit circle. So, within this unit circle only you are going to get so many circles here. And as you are traveling from outermost circle to the smallest circle, the radius, the resistance increases. Here the resistance is 0. Here the resistance is infinite. Exactly, if you come for this constant X circles basic equation is telling that its center is 1 and 1 by X, and its radius is 1 by X. So, for different values of this X, we have drawn all these circles, which is nothing but the constant X circles. And here what you have to observe is, here it is 1, 0 point, from this only every circle is originating, and here also 1, 0 point is the common point for all these circles. So, if you want to prepare the Smith chart, then superimpose these R circles on this one. Then you are going to get the complete Smith chart, which is already explained in the previous class. So, now in this class, let us find out some important points to do some type of problems using the Smith chart, because you know very well Smith chart is developed to do so many number of problems without any mathematical calculations. That means within no time we are going to tell the answer if you have a grip on the Smith chart. But only thing that is requirement here is the experience what you have. If you have a little experience with the Smith chart, and even with the calculator also you can get some time to get the results, but whereas using the Smith chart you can do so many number of calculations and without spending much more time. So, now before going to do the problems, let us summarize some points from these R circles and X circles. Now, try to concentrate on this point. I would like to tell you what exactly the Smith chart is. Here you see, this side is the point is at open circuit, POC, and here it is PSC, that means short circuit. So, it is well known that from R circles and X circles, here you see, here the R is equal to infinity. This point at 1, 0 is R is equal to infinity. From the reactant circles also, X is equal to either plus or minus infinity. Plus infinity means very simple. It is telling about the inductive. Plus x means inductive and minus x means capacitive. But the resistance will not be having those values. It is having only one value here. So at the point P, you are having here x is equal to infinity and here also at r is equal to infinity. So what is the impedance at this point? Impedance Z is equal to, I can say, r plus jx. You know this, jx. What is r here? R is equal to infinity and j is also infinity. So infinity plus j infinity means it is infinity. That means open circuit. So the impedance is maximum at this point. That's why in our chart we are having POC. Now coming for this point, okay, it is r is equal to 0. It is r is equal to 0 and here it is also x is equal to 0. So what is the impedance here? Z is equal to 0 plus J0, resistance plus reactance. That's why this point is called as short circuit point. And this is nothing but a open circuit point. That's why coming to our diagram here, and this is nothing but the open circuit point and this is nothing but the short circuit point here. Now you have to remember one thing here. Whenever you are going towards this point, that means in this direction, and you are going to get open circuit, and here it is nothing but a short circuit like this. So V maximum also will be in the direction of POC and V minimum is also in the direction of PSC like this. So before going for that, actually I would like to tell you how to utilize this Smith chart. Remember friends, Smith chart is having basically on the periphery, it is having three scales. Number one, the inner scale. This is nothing but the inner scale here. This is the inner scale. Scale 1. There are three scales here. This inner scale is nothing but a protractor. Protractor means what you are using from your childhood onwards. It is telling about the degrees. So this protractor is telling 0 degrees, 45, 90 degrees, 135, 180, and it is minus 135, minus 90, minus 45. So what is the use of this protractor? Protractor is always telling about the angle of the reflection coefficient. You know, reflection coefficient K is equal to ZR minus Z0 by ZR plus Z0. This is the basic definition of the reflection coefficient here. So if reflection coefficient will be having K is equal to some magnitude as well as phase angle. It is not a real number, it is a complex number. That is the reason I can say, in order to find the angle of this phi, protractor is readily available here. So this protractor is giving the information about this angle of a reflection coefficient K. And the magnitude, I can tell you how to find out the magnitude also. So protractor is telling about the angle of your reflection coefficient, because after all Smith chart is nothing but the graphical representation of the reflection coefficient in a complex plane. Okay, so that's why. Now another two scales are here, the next scale and the next scale. If you take this outermost scale here, this is the outermost scale, this is telling about the distance to the generator in terms of wavelengths. Wavelengths means lambdas. Suppose if you are taking this is 0.06 lambda, 0.12 lambda, 0.18 lambda, 0.25 lambda. Lambda means it is nothing but a wavelength, and that lambda can be calculated by velocity divided by frequency. Velocity divided by frequency. So the outermost scale is telling the distance on the transmission line from the generator. Remember this. If you take the in-between scale, this scale is there, this scale, and this scale is telling about the distance on the transmission line from the load end. So for our convenience, we are going to have different scales here, but of course one scale is sufficient. But why the three scales are here? So for the ready-made information on the chart, you are going to have different scales like this. That means three scales are readily available. So once you know this information, then definitely you can find out all the transmission line parameters within no time. Okay, so the distances are always expressed in terms of wavelength. Okay, and if you are taking the chart, this side you are having open circuit and this side will be having short circuit. And one more most important point is here. If you are taking a complete revolution on the chart, that is equal to half of the wavelength. So one complete revolution on the chart is equal to lambda by 2. That means this is equal to 360 degrees. So if you want to complete lambda means one wavelength. That means one wavelength is corresponding to 720 degrees. That means 2 times you have to rotate around the chart like this. What is this lambda? Lambda is nothing but the wavelength. So ఒక సైకిల్ మీరు కంప్లీట్ అవ్వాలి అంటే that definitely you have to go twice around the chart like this. Inchante if you are moving only once here, it is covering only 360 degrees. Okay, so that's why the outer scales are telling in terms of wavelengths, but whereas the inner scale is nothing but a protractor telling in terms of degrees like this. And of course you can use only one scale at a time, and one scale is sufficient to give the information around about this Smith chart here. Okay, so once you know this, then I can say V maximum occurs on the line OPOC, and V minimum occurs OPSC line. That means this line. Why? Because you know fundamentally, if you want to do this, V maximum is nothing but the maximum that is taking place on the transmission line. Now I would like to tell you why the V maximum occurs here and V minimum occurs here. V maximum occurs here because you know very well Zn maximum is equal to V maximum divided by I minimum. V maximum by I minimum. That I can write like this. This is equal to V maximum by V minimum. Okay, into V minimum by I minimum. That means I am multiplying with V minimum on both sides. So what is the V maximum, V minimum? That is nothing but you can say standing wave ratio, yes. And V minimum by I minimum is nothing but your Z0. So that is called Zn max. Zn is maximum. So Zn is maximum whenever V maximum occurs. Now the reason is why you are getting the V maximum to the right side of this O, right side of this center, because whenever you are moving from O to this place, you are moving towards infinity, because you know it is an open circuit. The impedance increases. So you are traveling in the direction of increasing value of your impedance. That's why Zn maximum is also in this direction. If Zn maximum is there, then V maximum is also in this direction. Similarly, whenever you are traveling from O to this PSC, you are having V minimum. That means Zn minimum, because traveling toward this PSC means you are moving towards 0, which is nothing but a short circuit. So left side you are moving towards a short circuit, and if you are moving towards right side means you are moving to open circuit like this, because your transmission line is also telling, and this is nothing but your open circuit and this is nothing but your short circuit here. Okay, this is open circuit and this is the short circuit. Now I hope you understood there are 3 scales here. Another one is nothing but the protractor, and the next one is nothing but the scale in terms of wavelengths, and the last one is also scale in terms of wavelengths. The last one is towards the generator, and whereas the second one is in between scale is nothing but towards the load like this. So once you know how to read the Smith chart, then definitely we are going to do so many number of problems using this Smith chart. Okay, I hope you understood the properties of the Smith chart. Very simple. Once again I am telling you, V maximum occurs on POC, and V minimum occurs from O to PSC. This is nothing but a protractor which is telling about the phase angle of your reflection coefficient, and the other 2 scales are telling about the distance on the transmission line from load and the other one is nothing from generator. So in order to get the ready-made information on the chart, he has provided so many scales around this periphery. So once you know this, then one more most important point is, if you are moving towards like this, that means if you are moving in this clockwise direction, this direction is called as clockwise. It is called as towards the generator. And if you are coming in the anti-clockwise direction, means counter-clockwise direction, it is called as towards the load. Then you have to decide, depends on your problem, whether you are moving towards the load or towards the generator. If you do 2 or 3 problems using the Smith chart, within no time you are going to get the answers. So in the next class what we do is, we are going to do some problems using this basic chart, which is nothing but a Smith chart. Then everybody can understand why it is so famous. Okay, I hope you understood the properties of the Smith chart, which we have discussed based on the constructions of your R circles and X circles. Okay, thank you.